We're going to walk through an example where we're going to estimate the area under the graph of a function. In our example, we're going to estimate the area under the graph of y is equal to 16 minus x squared. That's just a parabola that's curving downward from x is equal to 0 to x is equal to 4. And we're going to use 4 rectangles. And we'll use right-hand endpoints in part A, and then in part B, we're going to use left-hand endpoints, and in part C, we're going to use midpoints. I went ahead and graphed our curve, and let's go ahead and let's do part A. For part A, we are using right-hand endpoints. These are these points right here to approximate the height of each rectangle. And notice that there are 4 rectangles. Let's start by making a note that the area of each rectangle can be approximated by the height times the width. Notice that since we have 4 rectangles and our region is from 0 to 4, the width of each rectangle is going to equal 1. Our height is going to be approximated by our function y is equal to 16 minus x squared, and we're going to let that equal f of x. That will just help when we put it into our formula. Our area is approximately the area of our first rectangle, and this point is f of 1. So we have our height, f of 1, times our width, which is 1. And then our second rectangle has a height of f at 2. So we add on f of 2 times 1. And then our third rectangle has a height of f of 3. So we have f of 3 times 1. And then our last rectangle has a height of f of 4. We'll go ahead and put it down even though f of 4 is equal to 0. So we have f of 4 times 1. Now let's plug in what our function is. Our function is 16 minus x squared. So f of 1 is just 16 minus 1 times 1, which we won't write down. And then our f of 2 is 16 minus 2 squared. And then f of 3 is 16 minus 3 squared. And then we'll go ahead and put down that our f of 4 is 16 minus 4 squared, even though that's 0. Now let's see what this gives us. This is 15 plus 16 minus 4, which is 12. And then we have a 16 minus 9, which is 7. And then we have our 0. So we can say that our area is approximately, let's see, we had 27 plus 7, so that is 34. We can say then that when we use right-hand endpoints and we have 4 rectangles, our area is approximately 34. Now we're going to do the same thing, except in part B, instead of using right-hand endpoints, we're going to use left-hand endpoints. Let me go ahead and highlight those. There's our first one, second one, third one, and fourth one. Just so that we have it, I'm again going to write down that y is equal to 16 minus x squared, and that is our f of x. Now let's write down our formula for our area. It is approximately the height at our first endpoint. So this is going to be f at 0. So we have f at 0 times 1. And then our next one is f of 1. That gives us f of 1 times 1. Hopefully you're getting the hang of this. This one is f of 2. So we have f of 2 times 1. And then our last one, we have f at 3 times 1. Now let's go ahead and put this into our function 16 minus x squared. Our first one gives us 16 minus 0 squared. We're going to ignore the ones for the width. And then our next one is 16 minus 1 squared. And then we have 16 minus 2 squared. And then our last one is 16 minus 3 squared. Our area is then approximately 16 plus 16 minus 1 is 15. And then we have 16 minus 2 squared. So we'll write that down as 16 minus 4. And then our last one, we have 16 minus 9. This is approximately 16 plus 15, that's 31. And then we have 16 minus 4 is 12. And then 16 minus 9 is 7. So our area is approximately 31 plus 12 plus 7, that is 19. Our area then is approximately equal to 50. Let's now look at part C. For this part, we are going to approximate the height using midpoints. This is harder than left-hand endpoints and right-hand endpoints because we usually have fractions. Let's go ahead and let's put down what the x value is for each of our midpoints. Our first one is going to be 1/2. Our second one is going to be 3/2. Our third one is going to be, 2 plus 1/2, so that's 5/2. And then 3 plus 1/2 gives us 7/2. Now we'll write down that y is again equal to 16 minus x squared, and that is f of x. Now we can go ahead and write down the formula for our approximate area. It is going to be f at our first midpoint, which is 1/2, times our width, which is 1, plus f times our second midpoint, that is at 3/2, times 1, plus f at our third midpoint, which is 5/2, times 1, and then our last one is f at 7/2, times 1. Let's now use our formula that f is 16 minus x squared. Our first one gives us 16 minus 1/2 squared, so that's 16 minus 1/4. And then we have 16 minus 3/2 squared, so that's minus 9/4. And then our next one is 16 minus 25/4. And our last one is 16 minus 49/4. So you can see it gets a little bit complicated because we end up having to add fractions. One thing that is going to make our calculation a lot easier is if we go ahead and we add all 4 of our 16s together. So this is going to be 16 times 4. And then we're going to subtract 1/4, 9/4, minus 25/4, and minus 49/4. Let's see what this gives us. 16 times 4 is 64. And let's do this in pieces. Let's look at these pieces first. We have minus 1, minus 9, that gives us minus 10, and then minus 25. So that is minus 35/4. And then our last one is minus 49/4. And this is 64 minus 84/4. That's really nice because 84/4 is 21. So our area is approximately 64 minus 21. And that gives us an approximate area of 43. Now that we're done with these calculations, I want to do a little comparison. I actually went ahead and calculated the exact area. That can be done using integration, and we're going to get to that in some upcoming lessons. Let me just write down that our exact area, I'm just looking for an open space here, is equal to 128 divided by 3, and that is approximately 42.67. So let's go ahead and let's compare our approximations to this exact area. Let's go back up here to part A. We got that our area was approximately 34. That is less than our exact area, and we expect that because if you look here at our graph, you can see that our rectangles are smaller than the area under our blue curve. Let's now go to part B. I'm looking right here. Our approximate area was 50. That is bigger than the exact area. And that also makes sense because if you look at our graph, the area under our rectangles is bigger than the area under our curve. And then for our last one, down here at the bottom, our area is really close to our exact area, which is pretty amazing considering we only used 4 approximating rectangles.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.